The GEE Time Series Explorer offers an easy access to satellite archives stored in the Earth Engine data catalog. After selecting a collection, you'll see all available bands and a predefined subset of spectral indices. The Band Properties tab gives you a detailed overview of band properties, and in the Spectral Indices tab, you can choose from over 100 predefined indices. To explore a collection, choose the band and click on the map to load and visualize the full temporal profile for that location. While hovering over the plot, you get basic information about the image under the cursor, like the image ID, the acquisition time, and the actual band values. Plotting options like color, line thickness, and point size can be changed. Use the mouse to freely adjust the plot extent and aspect ratio. With a left mouse button click on a data point, you can visualize the associated image as a WMS layer. Clicking further data points will automatically update the WMS layer. This enables a rapid exploration of available imagery. You may use a date range filter to limit data requests to a temporal range of interest. Use an image property filter to focus on images with certain properties, like low cloud coverage. Note that your WMS layer can't be styled using standard QGIS layer styling widgets because it contains already rendered RGB values delivered by Earth Engine. Nevertheless, with the provided styling widget, it is easy to select an RGB multiband color visualization and apply proper contrast stretching. Note that through this single WMS layer, you have instant access to multi-petabyte of satellite imagery stored in the Earth Engine data catalog without any preceded data download. You may also change the renderer type to single-band pseudocolor. One of the most powerful features in the Earth Engine is to build image composites by aggregating and mosaicing collections over space and time. An image composite is also provided via a WMS layer. Technically, it is a spatially unbound image. It can be explored seamlessly from native resolution up to fully zoomed out planetary scale, and at every scale in between. When working with image composites, you don't want to filter your collections by image properties because you would lose too much data with the crude cloud cover filter. Instead, we use pixel quality filtering that operates on individual pixels. By ensuring pixel quality, we are able to create cloud-free image composites, but we may still have certain no-data regions. This effect can be reduced or eliminated by widening the date range. After we are happy with our specifications, we may use the temporal navigation buttons to systematically step through yearly image composites. A sample-based analysis is a common use case that we support by allowing the user to navigate to locations stored in a point vector layer. We also support the batch download of all profiles and image chips in a 512 x 512 pixel neighborhood around the point locations. As a more experimental feature, we added support vector regression for interactive profile fitting. We may introduce user-defined fitting approaches in the future to support individual use cases like the detection of forest clear-cutting or forest fire events.